Educate me. Is it or is it not more expensive? And if so, why or why not?
I think it's crucial to distinguish these two completely different kinds of things. Carbon removal is inherently expensive. We can disagree about exactly how much, but it's expensive. Putting sulfates in the aerosol is potentially so cheap that costs are irrelevant, in the same sense as when you think about security strategy, that actual cost of nuclear warheads is not a big driver in security strategy. Costs are so cheap that the richest people on the planet could perhaps afford to buy an ice age, that individual small states could act alone. So essentially, that doesn't mean you should do it, but it means that this will be a risk-to-risk
How would you distribute
decision.
that? Educate us on that.
Pardon?
How would you're saying it's so cheap. What is it makes it so cheap?
The underlying physical fact that it's so cheap is that a couple of grams of sulfur in the stratosphere offsets a ton of CO2 in the atmosphere, not in terms of all the environmental effects, but in terms of the crude radiative forcing. So I'm working with one of the leading contractors of high-altitude aircraft in the U.S., Aurora Flight Sciences. We're in the middle of a contract they have with us looking at the costs of doing this, and the costs are, as we thought, small. These costs
Would you add it to the fuel, or would it?
No, that doesn't work at all. That's in the blogosphere. No, you build custom aircraft that would fly at about 75,000 feet, that would put the appropriate sulfur, whatever it is, in the atmosphere. And the costs of doing that really work out to be low enough that costs don't matter. We're talking about a cost to offset the entire effect of double CO2 that's of order of just billions a year. So that's 100 to 1,000 times cheaper.
When you say offset the entire effects of CO2,
in terms of gross radiative forcing, as I've said and we've all said, it can't solve all the problems.
only on the radiant side.
Yeah.
This would have, my guess, and I may be wrong, would have no impact on ocean acidification.
None at all.
Okay, and I think it's really important to understand that.
Absolutely. So this is inherently imperfect. It can't compensate for CO2 in the air completely, but it can provide an extraordinarily fast-acting thing. And this business of it being cheap, I think, is pretty much a fact. And this isn't necessarily a good thing. The downside is it allows unilateral action.
Mm-hmm. How long does it last up there?
The lifetimes are years.
What, years?
Couple years.
And then it precipitates out, or
Yeah, that's correct.
no toxic side effects that we know of?
The thing we always wonder about is the unknown unknown.
Yeah.
So if you're thinking about, say, the acidification, it's clear that's not a problem. There's several studies that showed that.
Right.
But of course, the concern here is with so little research, there may be some unknown that comes out of left field that bites us.